basically what we are working is a predictive summarization. The idea is combining prediction and summarization. So how the economy will look like in future, that is a predictive summarization. And in short, it is telling maybe just few lines. And this is, we are doing some interesting work that we believe at least. Yeah, and then this is the offshoot of this, because this Myanmar student actually, Ray is short name, Shun. He's a lawyer actually. He did his law. He did LLB, LLM, and then came to digital business innovation and did his bachelor's. Okay, so this student actually tried to do some interesting work, and that I'm going to present you. This is the, and many individuals talked about RAG. So it's a good platform for us. And we are going to talk about graph RAG. Okay. So these are the basically, and I have only 15 minutes, but I don't, actually, I'm not used to speak so less, but anyway, I will try to. And it's not good thing, but anyway, I will try to speak very less and be concise. Anyway, professors are not used to talk less. So, so anyway, so I will, and these are the contents. Anyway, you can read it. I will not go through it. So we'll go to introduction. So basically, legal system itself is complicated in any country. And Myanmar is very complicated because it has English, it has Burmese language. There is actually a lot of complexity in political environment. A lot of legal cases are going on, and it's a multilingual legal system actually. And so there come another aspect: cross information retrieval and MLIR, that is multilingual information retrieval. And interestingly, we are working more into information retrieval because the application is different. Second thing is legal aspects have some contextual understanding you need, because you can't just use any information retrieval for. And I have some examples that your all LLMs give very absurd results when you use in legal system, and it can't be used as it is. So probably you require something different. Bias in legal decision prediction, another thing. Lack of Burmese language processing, and Burmese language is very interesting, though I don't know about it. Yeah, that is Ray's knowledge. So anyway, he wanted to be online, but somehow Japan, I think it's already late, and he's traveling to his hometown, so probably he could not do it. Uh, then LLM hallucination, because this hallucination anyway, we have issue of hallucination. We are even working on LLM unlearning, because LLM there is an issue that you learn on wrong information and then unlearning is very complicated. And there are gradient ascent models, scale diversion models to unlearn, but most of the models go into catastrophic collapse. So finally, just you can't use LLM after that. So again, you have to retrain. So it's as good as not de-learning. It is scrapping the model. So that probably another issue. So we'll say that graph RAG in some way addresses some of the issues. Not exactly. It could not be the solution. So just graph RAG. This is a typical architecture I've taken from this thing. And there is a contextual understanding in low resource languages is the focus. So if you look at it, just literature will briefly what there's a predictive summarization. We did a lot of work. We even have a product which is used by Tata consumers, and which has Tata Consumers is the biggest company. Tata is the biggest group, and actually, I published one book, Knowledge Innovation Strategy. Ratan Tata himself given a forward for that book. So Ratan Tata, he just passed away. He was the chairman of this group. They even own this Jaguar and Range Rovers now, and Tata Consultancy Services and all that. Okay, so so if you look at, there is a diverse linguistic domain-specific complexities, retrieving and summarizing archiving case studies, graphical representation, and graph RAG just that what we did. So our key claim is reducing hallucination in Burmese language. That is one of the key claims of this research. We can call it study also because it's on the borderline. Study plus research. Uh, uh, it's very specific, that's why research, but study because it has used some techniques, those are already in the market. So we don't want to claim that we invented it. Okay, so that's a very clear thing. So this is contribution. We introduced graph-rag-based legal information retrieval system for Burmese language. We propose rule-based and entity extraction from Burmese language. We conduct experimentation to support the claim and effectiveness. We further demonstrate the purpose of the method, and it's robust because the results prove that. And maybe you can visit the research paper to find out more details. So methodology, what we are doing. So if you look at it, so we collected data, and this is a Burmese data. We means basically Ray collected it. I don't understand. This is this language, but there is no spaces, and there are a lot of issues with Burmese language because then even like we do in English, tokenization and lemmatization and all that, the typical pre-processing, it's not possible with Burmese. You have to do different pre-processing. So anyway, if anyone Burmese can actually correct me if I'm doing mistake. Uh, uh, I think it would have been better if Ray would have been online. But anyway, so we collected that data. That is legal data, and he since he's a lawyer and he even fought couple of. He worked as a junior lawyer in couple of firms before joining TIU. So he actually had access and he got some data, and we used that data for this stuff. So data we organized. So the idea was that we created our structure. So we had defendant, decision, plaintiff, case category, citation, appeal, and all that. So we just tried to identify those details. Then you can look at this, the way we found it, and what we did based on that. We continued this. So final outcome of that case. Because what typically happens that the case data, retrieving that case data is very complicated. And we relate it to archival because you have so many cases, but you can't timely refer to those cases. So probably GraphRag could be one of the solutions because directly applying LLM may not be useful. The way someone has already discussed that you use RAG, what it does, it tries to get some external resources, external information, external knowledge. GraphRag is just on top of that. The information is represented as graph. And someone also pointed out that Node.js is used, graph are shown. So same way, the relationship, you're trying to identify the relationship. And relationship catches some more information, and further, it actually doesn't give the extra information, which is responsible for hallucination. So GraphRag gives to LLM the input, which is actually more clear in the form of relationship. So it is getting prompt and the knowledge graph. So if you go to the structure, basically, if you go to the structure, you're getting this knowledge graph, and basically we use Node.js, and we use some customized tools also on top of it to do that. And after that, so what is RAG anyway? All of you know, but if someone doesn't know, I thought a technique of enhancing the accuracy and reliability of generative AI models with facts fetched from the external sources. So you're trying to get the facts out. Second thing, it could help models clearly to reduce the ambiguity. So can it reduce the hallucination? That is the question now. So probably GraphRag could. That is our claim because we have both comparisons, and we found that GraphRag gives much better results. For example, the generative AI models supplemented with a medical index could give better results for medical. Same ways the legal graphs could help that LLM to produce better retrieval of legal cases, pointing to the exactly what is the outcome. So it is now in a way graph is getting the context, which probably absence of graph was getting the relationship, but which is ambiguous. So GraphRag in a way trying to get that out. So if you look at it, basic architecture, embedding the model, same thing, what I told, it's here. And it is the latter given to LLM. This is graph rack architecture, graph rack, where the search path includes the knowledge graph. So it is getting both inputs. Okay, so you have this generative AI model, Gen AI, and you're getting those prompts as well as these knowledge graphs. And then this output vectors and LLMs help you to produce the output. So if you look at it, overall methodology, you have entity extraction, you have structured data in a way because why we call it, because we are representing as a graph. We had idea, we were working with one mathematics professor that representing it as a semi-graph. The semi-graph, I think someone is mathematics professor, he must, they can even relate it better because we tried in summarization to represent summary as a semi-graph rather than regular graph because there could be multiple edges possible and for the same thing. And that can actually a better representation of summary than regular normal graph because normal graph we have V comma E type of representation. Semi-graph has slightly different representation. And we, so what that is next idea. There's a query processing, relevant document, embedding model, and you produce the outcomes. So there are some results. Finally, you built in entity, this pipeline we generated, we got these results. These results, if you look at it, you get more relevant information. So we, now the question came and we generated the prompt as we do, and we have these results. And this again, the same architecture, but I will, and I have 15 minutes and I must have surpassed them, so I will be a bit quick. So examples of hallucination. So again, there is a little bit of Burmese, but basically hallucination means what you can understand that the wrong information, it's not grounded. Basically what happens that it's not factual. So how to measure the accuracy is a question. So they generally measure it with Rouge matrix. Rouge matrix is like a precision, same way we calculate precision and F1, but it is more with the word matching or sentence matching. If anyone knows it, summarization, we typically use Rouge matrix for accuracy measurement. Now, what we thought, whether Rouge is really a measure. Because what happens that if synonym is there, Rouge fits. If it is a synonym, Rouge fits. Or we use the same word in completely different context, the Rouge accuracy may go down. So we actually came up with a new evaluation also. So that is another contribution here. So we'll go to evaluation. So we thought that this is a typical cluster. So we came up with a cluster matching score. So we, instead of the word, we create word cluster. And we calculate cluster-based Rouge. Not a difficult idea, but I think it's very interesting. And this cluster-based Rouge is actually, I think, even better than hallucination. This is a major contribution because no literature so far has come up with a cluster-based Rouge for evaluation, eating the accuracy of summarization, or even for hallucination or any answer generation, because it's a question answering at the end of the day. See, all information retrievals are becoming question answering, and all question answering are becoming summarization. So in a way, tomorrow, everything is a summarization. Because what, how the, who is XYZ is a summary about that person. So at the end of the day, tomorrow, nothing is a retrieval as such. These all disciplines are merging in a way. And we have this cluster. So we get the cluster cardinality. And based on that same Rouge we have applied to clusters. And this there are the results for this. Anyway, this is typical Rouge matrix. Yeah. And these are results. And you find that we applied it on GPT 4.0 mini, GPT 4, and all that. You find those results with Rouge L, Rouge 2, Rouge 1. And these we even give the same name, but we use our cluster-based rules, right? So because and basically this comparison anyway, I don't know. Yeah, he has to. Sorry for that. Yeah. Anyway, but it's actually multilingual. There is one person who can't. We are working on Bangladesh. Only one Bangla, and only one person can speak Bangla. We are working on Burmese. Only one person can speak. We another student. He is from Kyrgyzstan. He is working on Kyrgyz, and other can't. So and it's very difficult to work. But anyway, they are taking other role, language specific role to do that work without because we can't get so many candidates working on the same thing, and I can't learn those languages at this age, I think. Okay, so anyway, so that's more or less. So these are the limitations: complexity of legal language, dependency on the quality of input, scalability of computing resources.